In this video, we're going to look at a few more examples of evaluating a function when you're given the equation. So here we've got a function given f of x is equal to x squared plus 1, find, and in the first one we're asked to find f of 2. So again, as we saw in the previous video, we're going to substitute 2 in everywhere we had an x. So 2 squared plus 1 is equal to 4 plus 1 is equal to 5. So f of 2 is equal to 5. Pretty straightforward. And here's a different looking example. We've got a instead of x. So all we've done actually is we've substituted in another variable, a, for x. Although it seems a little unusual at first, we do the same thing. We put in a everywhere we had x. So f of a is equal to a squared plus 1. Now in the next example, we don't see anything changed here inside of the brackets. We've got a 3 out front. So it's saying, what is 3 times f of x? Although these brackets don't mean multiplication, that 3 is multiplied by, you could imagine brackets here like that. That 3 is multiplied by the whole of f of x. So to do that, we would think back to our golden rule of algebra. Whatever we've done to one side, we do to the other. So we've multiplied the whole left side by 3, which means we have to multiply the whole right side by 3. So 3 f of x is equal to 3 times x squared plus 1, and then distributing the 3 out, we get 3x squared plus 3. Okay, so when we have a 3 or some other number out front, that means it's multiplied by the whole output f of x. So we've multiplied the whole left side by 3, we have to multiply the whole right side by 3, and then we distribute. Let's look at a few more examples. Still with the same function, f of x is equal to f of x is equal to x squared plus 1. First example, now it's asking us find 3 times f of 1. So on the left side, we've multiplied the whole thing by 3 and we've substituted in a 1 here. So we have to do the same thing on the right hand side. 3 times, that's going to be 1 squared plus 1. So that is 3 times 1 squared is 1 plus 1 is going to be equal to 3 times 2, which is equal to 6. So 3 times f of 1 is equal to 6. In the next one, now we've replaced x with x minus 2. So everywhere on the left we had an x, which was only one place, we replace it with an x minus 2. That means we have to do the same thing on the right-hand side. So whereas we had x squared plus 1 before, now we have to replace that x squared here. Sorry, we have to replace the x, excuse me, not the x squared. We replace the x with x minus 2. So we put x minus 2 in there. We get x minus 2 all squared, or quantity squared, plus 1. Now if we wanted to simplify that, we would FOIL out. We get x squared minus 4x plus 4, and then plus 1 is equal to x squared minus 4x plus 5. Last one, negative f of x minus 2. So again, we have a negative out front, just like we had a 3 out front, means the whole thing gets multiplied by negative 1. Now, we're going to use the fact that we already figured out what f of x minus 2 is here. We know that f of x minus 2 is this. So negative f of x minus 2 is equal to negative 1 times x squared minus 4x plus 5. And then distributing the negative 1 to get rid of the brackets, we get negative x squared plus 4x minus 5. Okay, so the negative out front gets distributed throughout.